Hello all, welcome. In this video, we'll talk about rapid agent development with Antigravity. Antigravity is an IDE which is agent based. What you have is Antigravity in your development environment. It is on your local workstation with the rapid agent development skills that we'll install. We'll provide the requirements and using the skills, we'll start defining the architecture, developing code, testing, including testing using the browser and deploying that code onto agent engine, and then finally registering through to Gemini Enterprise. We'll generate architecture documents, we'll generate code. Although I'm not covering generating business value and blog posts, those skills are also available. So basically this is a complete hands-off approach, all formalizing the vibe coding. Just by talking to Antigravity in English, we can build agents very fast. So let us jump right in. This is Antigravity. Once you install it, let's now install the Rapid Agent Developer Skills. I'll provide a link to this Rapid Agent Developer Skills GitHub repo. All you just need to do is ask it to install. And in a few minutes, you'll have the skills installed and you can start seeing the list of skills that are available. You can inquire the list of all the skills. And it shows that you have different kinds of skills. The skills of interest for this video are ADK developer skill, the ADK tester skill, mainly the agent architect, that's where we'll start. We also have a browser tester skill, the deployer skill, Gemini Enterprise agent registrar skill that makes it available on Gemini Enterprise. Now that we have the skills installed, let's load the agent architect skill. This also loads the design templates that comes along with it. Now we can supply a requirements document to this skill to start building architecture. Now the example that we have is a Care Connect navigator, and this is to the employees of an organization to find a health provider and also book appointments with the health provider. We'll just use these textual requirements as the input, and we'll say, hey, for the conceptual requirements defined here, generate the architecture. So I'm just copy pasting the entire requirements and I'm saying, hey, generate the architecture for me. So once submitted, the architect skill will analyze those requirements and it'll come back with questions. It doesn't make all the decisions by itself, but it'll take the user's input. It creates an implementation plan and it is asking a few questions for us. These are architecture questions. One is about the user's context, how it will pass in, how tools and APIs are applied. Does it generate its own APIs or should it depend on some external APIs? And how does it handle the multi-tenant behavior? So these are architectural questions that we can answer. Another key question it asks is about the architecture, whether it should be a single agent architecture or multi-agent. It is proposing a single agent architecture for these requirements, and we'll accept that. Once the questions are answered, it goes ahead and generates the architecture by analyzing the requirements. And it also has an implementation plan that it follows. It creates a separate folder for the agent and it places the architecture document there. Let's review the architecture document. Let's open it in preview mode. You'll see that it has different sections. There is the user problem statement, the key constraints, and kind of clarifications that it has taken from us. It also has a section for architecture design where it explains the design, how the agent will work. Also a system diagram. You can see that this is a mermaid code, but in order to view the mermaid code, let's also go ahead and install the extension for mermaid. And once the mermaid extension is installed, you'll start seeing the diagram now. Let's review the diagram. There is a user who is making the input request, and there is a Care Connect agent which actually is storing the session state, talking to the multiple APIs here, one for provider directory, one for calendar availability, other for the bookings. And there is also a sequence diagram that explains the flow of interaction. In case we find something is incorrect, we have the back and forth here where we can ask the agent to make the changes to the architecture if desired. You'll also notice that there is an evaluation plan here based on and the metrics that it will use to evaluate. and also test scenarios for multiple paths. You can also add more if required. Also, looking at development and testing considerations, you'll see that it will actually generate mock data and will add some conditions to generate additional mock data. We'll provide more details on how much mock data to generate. You can see how I'm adding those requirements by selecting a section and chatting with that. So based on the given additional requirements, it will regenerate the architecture and incorporate those changes into the architecture. You see how it is adding the mock data. Now as the next step, we'll ask it to implement this architecture and generate the code. At this point, it will take this input and it will load the agent developer skill and it will start writing code. So the agent developer skill is now building the code. It is asking me for cloud project ID and cloud location. I actually forgot one step. I need to log in using gcloud auth login and application default auth login for ADC. I'm doing both, and now I'm giving the project ID and the location so that it can start developing code. I'm making sure that it is the same project ID that I am authenticated to. It may take a few cycles and a few minutes for the code to be developed, and Antigravity will wait for your permission many times, so you need to allow it. So you should be watching what it is doing. It has already created some files, so let's start looking at what it has generated. Let's look at the agent.py. This is the ADK agent, root agent, and these are the instructions that so we can review the code, and here are the tools that it is using. Where are the tools coming from? They are coming from .tools, which is tools.py. So let's look at the tools. These are the implementations for setting the plan type and checking the provider and booking appointments. Also, there is a .env file here with the project selected project, and you can see on the right side that it has actually completed generating the code, and it is giving a summary of all the files that it has generated, which is what we have reviewed. Now that the code is generated, our next step would be to test this agent. So let's ask it to test. So this loads the tester skill and it will start testing. It has created a test file, replay.json, and the contents are being shown, and it is now running the tests. So this guy automatically tests the agent by running locally with ADK run. So the testing is now done. It is showing the results on how the user and agent interaction has happened. We can review that. As the next step, we'll ask it to test using ADK Web in the browser. So Antigravity will start ADK Web, and also it will generate a plan to test in the browser with all the steps it needs to do. I'm asking for end-to-end testing for all scenarios, so it has generated all scenarios. So now it is running ADK Web, and it brings up the browser and it automatically tests all the scenarios that were in the evaluation plan in the browser. You can watch and verify that it is testing everything. If needed, you can ask it to change the test plans and regenerate them and retest them. So it's all in your control in terms of how you instruct Antigravity to generate the test cases and test. Once the testing is complete, the automated testing, generally I'll try to do manual testing as well myself. So here I'm executing the tests myself manually. I want to make sure that everything is good in this manual testing. What I'm noticing is that it's not showing out of network doctors, which was not caught in that automated testing. So you always want to make sure that it is complete. I'm going to ask it to refactor the code, and refactoring is very similar to our original code development. I'm just giving additional requirements and I'm saying, hey, refactor the code for this reason. And it's now refactoring the code with an implementation plan. We can review the implementation plan and submit, and it will regenerate the agent code with all the changes, and it will test it again upon our instruction. I always want to make sure that the architecture is also up to date at the same time when it refactors the code. So here is the new test plan to test the out of network doctors, and it is testing it now. And from the tests that it has run, I am seeing that the out of network doctors are also showing up now. which is good. And once the test plan is confirmed, our next step would be to deploy this agent to the agent engine. So before deploying, I'm actually stopping the ADK web and starting the deployment. This loads up the Terraform deployer skill and it will start executing the Terraform based deployment. It will actually create a deploy folder inside the agent folder and then puts all the Terraform files in that and then executes the deployment. Deployment takes about 10 minutes to run, so you need to watch out for any things that you need to allow for the deployment to go through. You'll also notice that it adds a couple of flags. This is for telemetry into the environment file before deploying. It also adds a agent engine ignore file, which has the list of all the documents that it needs to ignore during deployment. The deployment is successfully complete and we have the ID for the reasoning engine. Now, if we go to Cloud Console, we can actually find the deployment here under the agents. Let's find the agent. If we go to Playground, we can actually test the agent right there in the Playground inside the agent engine in the Cloud Console. Let's test it. So the deployed agent is working as intended. And our next step would be to register this agent with Gemini Enterprise so that this agent is available within Gemini Enterprise. And I'm again invoking another skill, the registrar skill, to register this agent. So Gemini Enterprise Agent Registrar skill is now running to register this agent with a particular Gemini Enterprise app. And the registration is now complete. Now the agent is registered, and if we go to Cloud Console to the Gemini Enterprise app, we'll find the agent and we will allow users to use this agent. Now, if we access Gemini Enterprise app, we'll find the agent and we can test the agent from Gemini Enterprise itself. So that is the manual testing of this agent through Gemini Enterprise app. But can we automate this as well, right? This is where the next we can actually ask this testing to be done using the browser tester skill by providing the URL for Gemini Enterprise app, and it will create a plan for testing and it can do the testing for you, and that's what you're seeing now. Note that for this testing to work, you should be logged in as a user that has access to Gemini Enterprise app first. So, and the testing will continue. So here is how it is doing the testing. It is pretty slow, not as fast as what you're seeing here, but it will complete the testing. It is pretty good in navigating to Gemini Enterprise app, finding the appropriate agent and running the test. Finally, it generates a test report that you can review. So to summarize, we have seen how we can use rapid agent development with Antigravity to design, build, and deploy agents to agent engine and then making it available through Gemini Enterprise, as well as complete testing of these agents using the browser testing that comes with Antigravity. Thanks a lot for watching.